Hello, good evening, everyone. So today we are going to discuss topics covered in week 11. I hope you guys may have watched the video. So we'll take the concepts and your doubts. Okay. So till now, yeah. Any question from your side?
No, ma'am, no.
Okay. Till now we have studied some distributions, and then from last 2 weeks we are studying how to estimate any parameters, right? Like if your x, if we got to know that your x is following some distribution, let's say binomial, and then we know, then in that case we have two parameters, right? Which are those? N and P. So we studied estimations like maximum likelihood, Bayesian estimation, and method of moments. Three methods we learned how to estimate these parameters, right? What the values this what these values of parameters might be, right? This we have studied till now. Now we are going to one step forward, like how. So hypothesis testing is one of the very useful tool that we will come across in the real life problem and any real life scenarios. What does it mean by hypothesis testing? So anyone knows what is hypothesis testing and what we are going to learn there? Anyone?
Ma'am, something that we are thinking and prove that thinking. Like we assume anything and we have to prove that thing. Like
Yeah.
testing how it is correct or not.
Contradiction.
Yeah, or contradiction, or sometimes to, if for example, I'm just giving you an example. Let's say
We
there
will
are,
use the samples and get the unknown.
yeah, that's why we have created the base for all these things to come to this hypothesis testing. Like we have studied how to check whether your distribution continuous, discrete, and all these things, and then uh, how to estimate this parameter. Because if we know what is distribution, then one, it comes to distribution, then it comes to the parameter of the distribution, right? Then the question arises, if parameter not given, then how to estimate that? So we learned these methods: method of moments, maximum likelihood estimators, and Bayesian estimators, right? All this will help us to find out how to predict about this, how to get estimation for this parameters. For example, if it's a binomial distribution, then parameters are N and P. If it is normal, then parameters are mean and variance, right? And all such things. Now, there will be scenario. Let's say there are two companies, company A and company B. They are producing some, uh, let's say, water bottle. They are uh, better is to just take a pen. Okay, they are just producing writing pen. Then obviously these two company, both are the companies, so they will advertise you that, okay, the pen created by this company A is good. The person who will work in B, he will say that the pen, if you use pen generated by B, produced by B, then that will be used. Then how will you decide which one is correct? Who is saying the truth? When it comes to the comparison between the pen produced by company A, pen produced by company B. So now what will you do? As an end user, like as a student, you can like purchase any pen, right? For 1 month you will purchase this, and next month you will. For example, just consider you are a retailer. Okay, then what will you do? You want to purchase pen on bulk. Then this trial and error will not work, right? You need some concrete reason to buy a particular pen, pen A or pen B, right? Then what will you do? So for that reason, there are certain things in statistics that we will going to use and decide on the statistical parameter, what to choose and why to choose. Okay. For example, irrespective of pen, because we cannot like there is quantity, quality, both the things are there obviously in every what we say product. For example, bulb is a good idea to select, because let's say both are producing the same quality bulb. Now they are claiming that company A will claim that their bulb is good, and company B will say no, our bulb is good. Then what will say? What will check? So, for example, that company A is saying that the bulb produced by them will last for more than 70 hours. Okay, and then let's say this bulb are widely used in your region, any local region. So everyone believes that okay, this company A bulb is verified and trusted product. Okay, it happens, right? We use one product and we believe that okay, this product is the best. Now in the market, after some years, some company B arrives and they claims that our bulb will last more than 75 hours. And you went to purchase and got to know that okay, this is lasting for more than 75 hours, and the price of both the bulbs are same. Now the question arises for you, which bulb you should purchase. So what will you do as a buyer or customer?
B bulb.
We go through the older one,
Okay, why?
because I have trust that it uh, like its lifetime life of bulb is 70 hours.
Yeah, more than 70. Yeah,
Yes.
and this one is saying more than 75 hours. Now the question is tricky, because this person is saying, but no one has used it. But this doesn't mean that he's like a
Life.
liar. Yeah, he is lying, right? It's not guaranteed, and it's
Yes.
not guaranteed that he is true. Then
Yes.
what to do that in that
Then
case?
we will try first, ma'am, like for a sample.
Yeah. Yes, exactly. So for that, what statistician will do? He will take 100 samples or n samples, let's say, and we assume. So, do you know what does it mean by hypothesis? Even though in while studying in the previous lecture or some last whatever in the whole session, uh, we use some word that this is a hypothetical example. What does it mean by hypothesis? So hypothesis is some what we say, some comment that is not proven, right?
Yes, ma'am. It's like a
That is known
statement
as
which is not proved.
yeah, that is not proved. So what we do? We will collect some samples of bulb of company B, right? Because now because company A product is used and verified, right? So we are checking for this company B product, right? Even though if it so for that, their claim is that the bulb will last more than 75 hours, and so we will take an sample and have two things that is known as null hypothesis and alternative hypothesis. We say like that. Okay, null hypothesis is that, let's say, they are correct. Okay, so we will say if the lifetime of the bulb is more than 75 hours, then obviously we are going to choose B from next time onwards, right? Whenever we
Yes, ma'am.
purchase any bulb. So let's say H naught is a null hypothesis that says that uh, T for lifetime, okay, T is greater than 75, okay. Then now this is hypothesis. So obviously, whenever I am checking on any statement, I want reverse statement, opposite statement also, right? That we called as alternative hypothesis that will say that no, this tree is less or equal to 75 or what? Are we interested in this 75 or we are interested in this 70? So according to you, what should be there? See, I am just introducing. After that, I will explain what is null hypothesis, what is alternative. For example, if some company B is coming there and claiming for 75 hours, as a customer, what you are interested in 70 hours? Like, even though if it gives a lifespan more than 70 hours, then obviously you are going to choose bulb B, right? Because 70 hours guarantee was given by this A, company A. If any company B is is offering you some new product that is even minute better than A, then also you will go for that new product, right? Because both are costing the same, right? So we will say if this time t is greater than 70, then also fine, right? Then also you will go for the product B, isn't it?
But ma'am,
Hmm.
that hypothesis will be wrong, ma'am, that they are claiming 75 hours.
Yeah, exactly. So that's why we will put it here 75 only.
Yes,
Okay.
ma'am.
So then there are some tests that we will learn in today and in some few classes also, that how to check which hypothesis is going to be correct. Okay, so there are some tests that we will going to learn. So now for today, our main agenda is to learn how to what this null hypothesis and what alternative hypothesis. Okay, so did you get to got my point? What are we going to do? So there will be some claims, and this happens in real life also, right? Some new person comes and he claims something, then uh, for a time being we get confused, okay, who is true, who is false. And at that time, this, if it is about the product or verification is possible, we will apply this kind of stuffs and get to know that uh, with how much precision you want to accept that thing. Okay, that will also come into picture. You might have heard this confidence interval kind of things, right? That
Yes,
all
ma'am.
these procedures we will going to learn. Okay,
Ma'am,
yeah,
will we always check hypothesis with compared to some previous hypothesis or previous claims which is already proved?
it depends. It depends. Like for example, whatever we have generated here, H not like whatever we have created null hypothesis and hypothesis is about company B product only, right? That
Yes, ma'am.
if they are true, if their claim is true or false, right? We are
Yes,
checking
ma'am.
that. Instead of that, if we are interested in which bulb is good, A or B, in that case, we will be dealing with T A and TB, like uh, time lasting time for A and lasting time for B, right?
Yes, ma'am.
So in that case, we will be like this. Okay, B is claiming that uh, their bulb is more good than A. Then we will be our null hypothesis and alternate hypothesis will change.
Okay.
Okay, so
Yes.
any test in hypothesis testing, there are several tests. For any test, the base is this one, your null hypothesis and alternate hypothesis. What you will choose here, uh, that will lead to your answer, like whether it's uh, lead to your correct decision or not. So your whole solve decision will be based on this, your null hypothesis and alternative hypothesis. Okay. So let's go step by step. So is there any doubt like what are we going to do now onwards?
Ma'am, what
What
does it mean by test?
test? So see, here there were two companies and they were claiming something. So we are testing their claims. So their test. And actually, this was just hypothesis generation. Then tests are like you may have heard this Z test. Have you heard this? Z test, T test,
Yes,
student
ma'am.
count.
I saw the lectures.
Yeah, normalized student taste and this kind of tastes are there. So there are like many tastes, chi-square test, and so many. So that we will learn in some few lectures. Okay, for that the heading is like hypothesis testing. Okay, fine. So this was actually a real life example, but to start with this example will be quite tricky. So we will consider some basic example and start to learn with that. Okay, and then at the end we will try to connect it with this bulb example. Okay,
Okay, ma'am.
fine. So the first thing, whenever we have to decide, for example, let's take the same example that sir has taken in the lecture. Three toss are like three coins are tossed. Okay, or the basic example is yeah, if we take one coin, then it will be very trivial. So let's take three coins. Okay, three coins, or let's take one coin only, and we are tossing it for three times. Okay, fine. So there are, let's say, uh, there are two coins in front of you, and they are saying that okay, one coin is fair coin and one is not fair. Fine. Fair, what do you mean by fair coin? That means the probability of head and probability of tail is same, right?
Yes, ma'am.
That is fair coin. Now you are going to do some experiment that you are tossing a coin for three times, and after tossing you have to give the answer that uh, whichever coin you have picked, whether that coin is fair coin or not. Are you getting the question? There are two coins in front of you. Okay, coin one, and this is, let's say, coin two. Okay, and they says you, and both are looking almost similar. And the question is, by tossing a coin three times, how will you check whether your coin is biased or not, or let's say fair or not? Okay, so for that we can use this hypothesis things. How do you? So before going to that, do you have any idea how to claim that whether your coin is fair or not? How will you check? So generally, in this kind of situation, we cannot say anything with the guarantee, right? Because if both are looking similar, then question will be how to check it. And in real life scenario, we have seen that we know that even though it's a fair coin, it may be possible that you are getting head continuously, right? Because this is one of the probability when you toss a coin three times, right? So you cannot claim that
Yes.
that coin is biased by observing this result, right? It may be possible that you are getting this result HTH. In that case, it also may be possible that with the unbiased coin you are getting this result. Then how to decide?
Yes, ma'am.
So for that, we use this hypothesis kind of thing. See, this example is easy to understand, like how when we will accept a particular situation and when we reject particular situation. And just tell me one thing, even though you are doing this kind of experiments and setting some rules, is there any like 100% surety that you are correct always? because I give you two like typical outcomes of this three toss, right?
Yes, ma'am.
Similarly, this TTT is also one of the outcome. If someone is tossing a coin on first time, he got HHH, and second time TTT. What should he do? He should reject that. Okay, he should say that this coin which I have picked up, this is a like biased coin. Like this is not a fair coin because it's giving consecutively HHH, then consecutively TTT, right? So someone will claim that okay, this is biased coin, or just say it's not a fair coin, right? So is he will be true or false? Like even though with particular
We
step,
cannot say anything, na, ma'am.
Not certain, ma'am.
yeah. So, but still we have to claim something, right? So I'm just explaining how things works. May or may not work with this particular example, but see, still, what we will do, we will first decide what are the outcomes that you know. So I'm not writing, right? If you toss a coin 3 times, how many outcomes you will get?
8 outcomes.
8 outcomes, right? This okay. So should I write this cardinality as 8? Is it fine?
Yes, ma'am.
And the outcomes we all know, right? So I'm not writing all this. So if 8 outcomes are there, then the procedure says if you want to claim anything about the biasness of coin, so just fix any set, any subset of this omega, okay? And say that if your outcome falls into this set, then you will accept your null hypothesis. So first we have to decide, yeah, just a minute. Your like total outcomes are 8. So let's say we have to assume something, right? That is hypothesis statements. So what do you think? What should be our hypothesis? The H naught, that is known as null hypothesis. I'm just taking it as, in this particular case, you have a two coin 1 and 2, and you are just picking any coin and tossing it, and now you want to check whether your coin is biased or not, or even not two coins, just take one coin only, and now the question is you do not know anything about this coin, whether it's biased or not. Do you understand when I say bias, that means probability is not 0.5, right?
Yes.
Okay. So we are interested to check whether it's biased or not. So our null hypothesis is, let's say it's a fair coin, okay? And alternative hypothesis, HA, or someone will write it H1, both are the same thing, okay? This is my alternative hypothesis. Okay. So let's say H0 means fair coin, okay? It's a fair coin.
We are
Then
assuming that
yeah, we have to assume that because we are
we don't
searching.
know, we
Yeah.
don't know what the actual.
Yes, we don't
Sure.
know whether your coin is fair or not.
Yes, ma'am.
Okay. So how to check with that? So the setup, all of you understood what is the setup. So there is a one coin. We are tossing it for 3 times. Okay. Toss 3 times. So I just wrote what output. There will be 8 outputs. If I toss any coin for the 3 times, there will be 8 possibilities, right? 8 possible outcomes are there. So I'm choosing
Yes,
that, okay, H naught is my null hypothesis. Is null hypothesis means what? What are you assuming for that particular coin? So what do you want to assume for your that experiment? So I am just assuming it's a fair coin. Is it fine if you by observing you or you get to know that no, it's not a fair cell, then in case you can take your null hypothesis as this is a biased coin and HA is a fair coin. Okay, that's
Ma'am,
up to you.
can
Yeah.
we say null hypothesis is like what we are more probably about? What we think like it could be most
Yes,
probable?
yes.
Okay.
Yeah, null hypothesis is about that. But it varies also, like someone's practice. Also, it depends on that also, like how do you want to. But generally, in null hypothesis, we take those things that we are very sure of.
Yes.
Okay, so we have decided this like null hypothesis as it's a fair coin and alternative is it's not. Now, so we have to define some subset A of this omega, that whenever our outcome will belong to this set A, then in that case we'll accept the null hypothesis. Okay, that the coin is fair, otherwise not. Okay, are you getting? Like, let's say my A is for example HTH, EH, T, TTH, or HTT, for example, any subset you can take. Okay, any subset. This is a subset of omega, right?
What basis we take this A?
Yeah, what?
Because total outcomes are 8.
Mhm.
So on what basis we select the set A?
See, this is just an example to understand what is the acceptance region and what is the rejection region. So there are 8 like outcomes. So how many possible subsets are there? Number of
Ma'am, 2
subsets.
raised to power 8.
Yeah.
2 raised to the power 8.
So there are 2 raised to the power 8 choices for this A. We can choose any subset as our acceptance region. I just want you to explain what is acceptance region and what is rejection region, because in discrete example, it is easy to view how acceptance region and rejection region works. Okay. When it comes to continuous, then once you are clear with this imagination, then in continuous random variable, it will be easy to handle it. Okay.
But
So,
how this acceptance region will come to the role? Is it given or it is asked?
yeah, fine. So, what we'll do, ideally, this kind of practical is done with all the possibilities, that is 2 raised to the power 8 times. But for this particular, I just took any random subset, HTH, THT, and TTH. Okay, I just took it randomly. There not any particular rule is there. I have not used any particular rule. I just picked any subset of my omega, and I just considered this is my acceptance region, acceptance set. Okay, this is called as acceptance set. What does it mean by acceptance set? See, in discreteness, in discrete kind of example, these things do not work that much good, that much smooth as in continuous. When it comes to normal distribution, it will be very useful, and it's actually we are using in real life also. In data analysis kind of thing, we use this kind of hypothesis for any prediction or kind of things. But for with this example, my aim is to just clear what the acceptance set or acceptance region is. Now, because if I draw this kind of diagram that you may have seen very occasionally in your books and everywhere, in YouTube lectures also, if you visit any, that this is your acceptance region, and here you will look some alpha is there, and they will say, okay, this is your rejection region. Have you heard, have you seen anything like that?
Yes, ma'am.
Yes.
Yeah. If I start with this, then will be typical. So I just started with discrete now, with a small example.
Ma'am, one doubt.
Yeah.
Do we convert every distribution into normal and then solve for alpha and beta?
Okay. For that answer, I will ask you one thing. Have you attended last some lectures where we were using central limit theorems?
Yeah, I was there, week 9.
Yeah. What central limit theorem says? See, now this is your question is very good question, because the central limit theorem gives us one liberty that once your n increases with some particular after some particular number, every distribution's mean, that means the mean of the sample will follow what? Normal distribution.
Normal
distribution.
0, 1.
Yeah. So that is that we will use here in Z test and p value also. Okay. So
And ma'am, also with normal, it is easy to visualize and do it.
yeah, and there are lots of research have been done and studies have been done, and maximum of the thing that due to this central limit only, we are very sure that once your sample is very large, irrespective of your initial distribution, your mean distribution will lead to a normal distribution. Okay, just let me just continue with this. So define any particular subset and say that whenever your outcome, whenever your experiment will fall into A, you will say that okay, this is fair, otherwise not. Okay. Now, okay, do you understand how to get this acceptance, and in that particular set, what will be your rejection? Rejection set.
Complement.
Still not clear.
Obviously, A complement. Okay, then I will just tell you.
About
See,
this acceptance, how to go for that? How to
no,
go?
there is nothing that I can say about the discrete sets. You have to wait for just a real life problems. I
Okay,
think
ma'am.
in that case, see, here I am just explaining what is acceptance set. That means if your
Okay.
outcome falls into this set, then accept it. Like then accept your null hypothesis. Okay. Rejection
So,
set means
so will it be given? This set will be given in
no.
question,
This is just what we say
or how to?
example point of view. But for example, this bulk question. Okay. For
Okay.
example, this bulk question. If you draw a real line, then obviously you will have 0 hours, 1 hours, 2 hours, and so on, right? And somewhere 75 hours, that is your mean for this company B. That is your mean, right? And once they said it will last for 75 hours, or just say their average life is 75, so we will have something like this, right? Let's, for example. So
Yes, ma'am.
if the bulb lifespan will be around this region, we will say that okay, they are saying something correct. Okay, otherwise we will say okay, they are lying, right? So in this particular example, what we did, we just pointed out their average value and spread according to us, like that is something we called it as levels that we also discuss here, and that according based on that variation we will define some acceptance region. So if the time zone of the bulb, lifetime of the bulb will follow on this part, then we will say okay, their claim is acceptable, otherwise not. Okay, did you get?
Okay, ma'am. That
So,
remaining part is
so
our
when it
margin.
comes to real life example, it's easy to like claim anything, easy to predict acceptance region. But my aim was to just clear what is acceptance. That means there will be some set of values. If your test or a critical value or all these supporting factors will come into that acceptance set, then whatever you have decided as your null hypothesis, you can accept it with some confidence. That confidence thing also we'll learn, but not in this week, in next week.
Ma'am,
Okay. Yeah.
ma'am,
Hmm.
rejection set will always complement, na?
Yes, always. For example, this bulb example. If let's say I have just take the 10 hours what we say error, okay, so it will be some 65 and this will be 85. For particularly bulb, I will not use two-tailed. Okay, so there are hypothesis testing. In there also we have one tail, two-tail test. So this is two-tailed. If your bulb is lasting more than 85, you will not going to reject their claim, right? You will say, okay, once it is more than 75, I am satisfied. I will go for bulb B, right? So that's something.
Ma'am, these are average, na? What we are talking about.
Yeah, these are averages.
Okay. If average is greater than 85, then we can't conclude, and less than 65, then also we can't conclude.
No, if it is less than 65, then like for example, you have collected some sample and average comes below 65, then you will definitely reject your bulb B, right?
But it is greater than it. Okay.
Greater than 85 is in your favor as a customer,
Yes.
right?
Yeah.
We do not have a problem when we are getting a bulb which is lasting more than 85 hours, that whatever they are claiming.
Yes, ma'am.
Okay, fine. So this is what acceptance set, rejection set. Now, just tell me one thing. Even though you put this kind of setup, there will be some chances that error will occur, right?
Yes,
For
ma'am.
example, that someone is saying that, okay, this I am not getting. Why are you choosing this? That is also correct, because see, even though your outcomes are lying on this set A, what is the guarantee that? So according to our setup, we will accept that this is a fair coin if our outcome will lie on this set A, right? But what is the guarantee that it's possible, right? If a fair coin is there and you are tossing it for the first time, you got HHH. In the next term, you got TTT. Fine. In the next time, you got let's say something not here. HHT. Fine. And again you got HTH, and now you are getting this kind of stuff. So HTH was there, okay, fine, no problem. So you got consecutively 3 times you got an element that is in A complement, right? And initially, and someone is saying that no, this was a fair coin, your examiner. Then we did some error in choosing our acceptance region, right? That's why we are rejecting that this is not a fair coin. Are you getting my point? Let's say the coin was actually a fair coin, but when someone did the experiment, he got for the first time he got HHH, so he rejected. Why he rejected? Because his setup was like this: that if uh, the outcome do not fall in this, then I will reject my null hypothesis that the coin is fair, right? So you said it's unfair, like it's a biased coin. Then in the next time, again you got TTT, and again you will reject it, right? Why? Because of this setup. Are you getting it?
Yes, ma'am.
Yes.
So in real life also, when we do some setup, also there is like there is a possibility that some error will be there, right? So this is kind of error only. So in hypothesis, we have generally two kind of error. We say it as a type 1 error and type 2 error. So just without knowing any particular terminology, just a simple logic. Now we are ending up with this example, and just a simple logic. Let's say for a particular experiment, you decided your null hypothesis, you decided your alternative hypothesis, right? And you do not know which one is right or which one is false, right? That's why you assumed your hypothesis. Now just tell me, what are the possibilities of error here? H0, H1, type 1 error, type 2 error. So which one is type 1 or type 2? That is terminologies in statistics. But by just general observation, you just tell me there are two possibilities, H0 and H1. One is true, one is false. Even though all the setup is okay according to us, still there is a possibility of error. What are those errors? So it may be possible that we accept H1. Accepting H1 means, what does it mean by accepting H1?
Accepting the alternate
assumption
hypothesis.
is wrong.
Yeah, H0
Accepting
is,
and
yeah,
assumption is
null
wrong.
hypothesis is wrong. We generally do not say that H1 is right or H0 is wrong. The language is accept H1, reject H0. Okay. Okay. Accept H1. That means we are rejecting null hypothesis, right?
Yes, ma'am.
Rejecting null hypothesis. Okay. Just tell me one thing. Do you understood how to accept and reject the things based on the set?
Yes.
Yes, ma'am.
Okay. Okay. So there is a meaning to move ahead. Okay. So accept H1 means accept alternative hypothesis. That is nothing but we are rejecting null hypothesis, right?
Yes, ma'am.
So this is some terminology that you will come across while studying this kind of. Initially, these things will be confusing, but just read it carefully. They are the same things. Okay. So rejecting null hypothesis. So sometimes it may happen that you are rejecting null hypothesis, but actually that was correct. Is it
Yes, ma'am.
possible?
It could be possible.
It could be possible that you are rejecting null hypothesis, but actually it was correct.
If
For
we are
example,
choosing a a wrong set, because we are dependent on that set we have chosen for our acceptance set.
Ma'am,
Acceptance
H
and
naught,
rejection.
ma'am, we will always reject the H naught means null hypothesis, na?
no, we will not always reject. We in many of the time we accept null hypothesis. See, there is no rule that we will accept or reject. We will
It
totally
depends
take
what we
our
are.
decisions based on our taste, what taste says us.
Yes,
Sometimes Z taste, sometimes P value. Sometimes then T taste and all these things are there that are something. But today I will explain you Z taste and P value taste, how to check according to that. Okay. So the type 1 error says that type 1 error says that whenever we reject null hypothesis, but it was actually true, that condition is known as type 1 error. Do you understand? Do you get it? Like it's error, right?
Yes,
Because it
ma'am.
was true, but we are rejecting it.
It was supposed to be
So
accepted, and we have rejected it.
yeah, we rejected H0, but it was true when H0 is true. Okay. And what is type 2 error? Okay, before introducing that, let me just so this quantity is also one of the significant quantity. When we calculate this probability, then it will give us significance level. Okay, that we denote by alpha, and this is nothing but the probability of rejecting H0 given
Given
that
that H naught is true.
yeah, H0 is true. So this is somewhat significance level that we'll discuss in some time. And there is something called power of test or type 2 error. So which second kind of error you expect when we do such kind of tastings, that we have considered two statements, H0 and H1, two hypotheses. Then one error is we rejected this part even though it was correct. Now what kind of second kind of error? Anything possible here?
Accepted H1 when it is wrong.
Accepted H naught when
Except
it
H naught when HA is true.
Yeah, accepted null hypothesis when H1 was true. So
When
any,
alternative is true.
yeah, H1 or HA, whatever you say. Okay, alternative is true. Fine. And there is one quantity called as beta or power of taste, that is 1 minus beta, where beta is nothing but, yeah, anything, probability of what?
1 minus alpha.
Accepting. Yeah, this one only. Accepting H naught. Okay. Any specific example? Can you give real life situation where you have come across this kind of any?
Ma'am, I did not imagine an example in real life.
Okay. So let me give one hint. We have fire alarms in building, right?
Yes.
Yes, ma'am.
Okay.
yes,
ma'am.
ma'am.
For example, there is a fire alarm and it will ring whenever some fire is there. That is obvious, right?
Yes, ma'am.
So do
Yes,
you
ma'am.
know if someone smoke under that alarm, in that case also it will ring,
Yes,
right?
ma'am.
Yes, ma'am.
So there is a fire alarm in one building or one whatever, some building, okay, for example, and there it rang because someone smoke under that. So security have accepted the null. In that case, what will be your null hypothesis? Your
Ma'am,
alarm is
type
ringing
2
for the
error.
right reason or wrong reason? Yeah.
Wrong reason, ma'am. Type 2 error.
Okay. So H naught is, let's assume that your alarm is always correct. Okay. We'll assume that, right?
Yes, ma'am.
Because we have fire alarm. So we'll say that, okay, fire alarm is correct. Or, and H1 will be,
There is fire.
there is fire. Okay. H naught is, there is fire.
Ma'am,
Fine. Yeah.
ma'am, this is a hypothesis test is similar as the Bernoulli, right? That 0 will be failure and 1 will be success.
Yeah.
Can we say that?
Bernoulli, yes. H naught or H1 is like just a representation, but you can say HA also. The distribution depends on something else because for distribution we need data. Let's say, okay, come back to this example again. This is our hypothesis, and I give one scenario that fire alarm rang because someone smoke under it. Now, what the situation was, security has taken it as a okay, it's a valid situation, and they just informed everyone to come out. So what we did, we accepted null hypothesis, but actually
There
alternative
was no
was
fire.
true, right? There was
Yes,
no true.
ma'am.
So it was a type 2 error kind of thing situation. We accepted null hypothesis where alternative was true. There was no fire, right? Now it happened again and again, and now there was a situation when actually there was a fire. And in that case, if security takes the wrong action, that means rejected null hypothesis, then what will happen?
Type 1 error.
Type 1 error, ma'am.
Okay. So got it? This kind of,
It's very dangerous.
yeah.
Ma'am, can you please repeat again?
Okay. So, okay. So in the second case, when there was a actual fire and they thought, okay, always it's not fire, so they do not do this kind of stuff. That's why they will always take it seriously only. So
Okay.
there was no fire, but sorry, there was actual fire, and then by mistake someone thought that it's a false alarm, not a correct one, and they reject their null hypothesis. Reject null hypothesis means they do not take any action even though there was fire, right?
Yes, ma'am.
We rejected null hypothesis when actual fire was there. So that kind of thing is type 1. Okay.
Yes, ma'am.
So similar example you can form using that COVID RT-PCR example, right?
Yes,
There
ma'am.
was false negative, false true positive, all these stuffs were there at that time, right? Okay, so understood. These two types of error are there,
Ma'am,
type 1 error,
ma'am,
type
in
2.
the type 1 error, if we reject the H naught, then it
Mhm.
will be type 1 error. And if we accept the H naught, then it will be type 2 error.
See. No, it's not like that. When you reject null hypothesis, but it was true. It was true and we rejected, at that time it's an error. For example, if there was actually no fire, let me just repeat. For example, there was again no fire, that means someone smoked and security rejected to check up whether it's true or not. So he assumed that there is no fire and actually there was not fire. Why? Because someone was smoked under that, right? Are you getting me? He rejected H
Yes,
naught
ma'am.
and there was no fire. So that is not error. That is actually correct situation, no? In that case, he has to reject only. Reject null hypothesis, no? Because it's not feasible to empty the whole building again and again. Right? Are you getting it? And
Yes, ma'am.
so uh, error comes when it was rejected, H naught was rejected, but actually the condition was in favor of H naught. Okay? That kind of stuff comes under rejection. Okay?
Yes, ma'am.
So these are some errors that we find using this significance level alpha and what we say, power of test beta, 1 minus beta. Okay. So there is again one more thing that we call as power of test. What do you mean by power of test? Whatever the test we are going to do that. After that only we'll explain this kind of stuff, what they are. Okay, I'm just introducing terms here only. Okay. So is it clear till now? The hypothesis, what is
Yes.
null hypothesis, what is alternative, type 1 error, type 2 error. Okay. And what are this alpha and beta? They are just something metrics. On the basis of that, I will just introduce something that on the basis of alpha and beta, you will check whether to accept or reject. So these are the metrics. Okay. Do you know this metric kind of things?
No,
So
ma'am.
these are some metrics. Okay, metric means, for example, to measure the distance, you use centimeter kind of stuffs, right? So that is
Yes.
a centimeter. Someone will use foot and all this, inches. These are some metrics to measure the distance, right?
Yes,
Now,
ma'am.
to measure this test are correct or not, for that we will use this alpha and beta. That's why these are the metrics for our hypothesis testing. Okay.
Okay.
So some question we'll do on coming Tuesday to calculate all these steps. But today, just understand what are the concepts. Okay. Do you have classes at 8 today?
Yes,
Yes,
ma'am.
ma'am.
There is a math class.
Okay, fine. So let's take an example how this test will work, when to accept, when to reject. Okay. Just to
Okay.
introduce that thing only. Let me
Okay, ma'am.
just let's consider there are 100 tosses. Okay, 100 tosses of coin, and which would be either authentic and probably okay. Let me just present that screen only. That is removed. Again, the same example that sir has discussed and used. Okay, so there are 100 tosses of coins, and they might be fair coins or not. Okay, might be fair or not. Okay,
There's
fair
only one
coins.
coin. No?
Yeah, 100 toss of a coin. Yeah, there is only one coin that is we are tossing for the 100 times. Okay,
Yes.
it might be fair coin or not, and probability of, obviously, if it is authentic, that means fair coin, then probability of head will be what?
0.5.
0.5. So this says there is a coin that we are tossing for the 100 time, and it may or may not be fair. And if it is not fair, then probability might be fair with probability of head is equal to 0.5, and biased with probability, let's say 0.6. And
It will be
T,
given.
yeah, it is given. This I'm just writing question only.
Okay.
And T is number of heads. So we are tossing a coin for 100 times. So T is representing number of. Why I'm taking T, because this is kind of some standard notation. That's why I'm using it here. Number of heads seen.
Ma'am, maybe threshold.
Yeah. Threshold and just yeah, you can say that.
Okay.
Number of because threshold we generally denote by C, critical values. So
Oh.
it's given that like it is again given, or even if it is not given. Okay, now the question is if there is some constant C, now we have to check whether it's authentic or not. The coin is fair coin or not, and we tossed it for 100 times. How will you check? So it may be possible that someone will say, okay, just fix some number that if you get your number of heads, that is T. Okay, if number of heads out of this 100 are more than 55, then what will you say?
Biased coin.
If greater than 55, then I will say whether to accept or not. See, now
It is
we
a
have,
biased coin.
it is biased. Okay, you will say then it is
Reject.
okay. So basically, to have a fair coin, what we'll assume that the number of coins should be less or equal to 55. Is it fine if I say?
Yes, ma'am. Yes, ma'am.
Okay, let's say I will accept H naught. H naught is what? A fair coin. Okay,
Yes, ma'am.
H naught means fair coin. So I will accept H naught if accept H naught if T is less or equal to 55. Okay, is it fine? We
Yes,
can
ma'am.
have this kind
Ma'am,
of
why are we taking 55?
any number you can take. This is generally we say it as a T less or equal to C. We fix any C. This is critical value, and there is one relation between alpha and C. Alpha is what? That significance level. Generally, we fix our significance level first. And if we know the significance level, then based on that, we will find our critical value. Critical value means what might be the value of C so that you will accept or reject the things. Okay.
It's like a error we are taking.
Yeah, yeah.
Okay.
So significance level is what? Uh, it is related to some confidence, like how much error you can handle. Okay, how much error is accepted to you. That's up to us. Okay.
Yes,
Later
ma'am.
on, it will give you idea about the confidence interval. But for now, just take it as like the similar as we used to say in physics, significance. How much error you can, you are in that particular scenario, how much error is possible to handle.
Okay,
Fine.
ma'am.
So now you tossed a coin, so we have to define whether we'll accept or not. So this is our acceptance region. That means whenever the number of heads are less or equal to 55, we will accept that our coin is fair. Otherwise, we will not. Okay.
Yes, ma'am.
So let's say alpha is what? Alpha was what? Significance level. It was probability of rejecting null, right? When H naught was true.
Yes,
Type 1
ma'am.
error. Probability of type 1 error. So if I write in terms of T, then what should I write? I am rejecting H naught. Rejecting H naught means T is
Less
Greater
than or equal to 55.
than,
T is
greater than.
greater than 55, no?
Yes, ma'am.
Rejecting H naught, T greater
Yeah.
than 55. Given that, or just say it A or B, that is also fine. Okay, okay, fine. T is
Greater than 55.
greater than 55. Given that H naught is true means
So T less
probability
than
is 0.5,
okay. Yeah.
right? H naught is true means that is a fair coin. Fair coins mean probability of head is 0.5,
Yes, ma'am.
right? Or we say it as a, let's say this is our acceptance set, so just say it as A and say it as A complement. So someone will say it as a probability that we rejected means we accepted null, given that H naught was true, right?
Yes, ma'am.
Okay, fine. So out of this 100 tosses, more than 55, like numbers of head we observed is more than 55, right? What kind of distribution is it? T is greater than 55 means there will be a situation that T is equal to 56, T is equal to 57, and so on, right?
Yes, ma'am.
Out of
Yes, ma'am.
100, we got 56 heads. So does it look like binomial distribution? There are 100 tosses, and out of 100, we are getting 56 heads, 57 heads.
Yes,
So
ma'am.
is it something like out of 100 tosses, we are getting some number of heads, that is k, right? What k should be more than?
55.
Yeah. So k is 56 to 100. And then it was a fair coin. So probability is 1 by 2, right?
Half.
So
Yes,
100 and 100 and sorry, yeah, k and 100 minus k, right? So I just added it. Is it fine?
yes, ma'am.
Okay. So that will be our value of alpha, right? Similarly, we can calculate 1 minus beta on that basis also. So this
Ma'am,
is how, yeah.
in this, we will find the alpha is equal to given the condition probability, na?
Uh, Conditional, yeah, H naught
Probability.
was true, yeah.
So then we will use the formula is equal to probability of A in is equal to probability of A intersection B upon probability of B, na?
Yeah, but how will we use that here? Like that will be t greater than 55 and probability h is equal to 0.5. See,
We will write this as probability of t greater than 55 intersection of probability of x is equal to 0.5
0.5.
upon probability of x is equal to 0.5.
Yeah, so even though you go with that also, we will end up with this one only. You can try that also. Because what we did, we just directly put that things here, right? We applied the situation that probability of head is 0.5, because see, t greater than 55 means the probability of head is 0.6, right?
Yes, ma'am.
According to our setup. So whenever you will take that intersection, you have to take that things into account. But what we did, we just merged both the things together, that its t is greater than 55 and probability of head is also 0.5. So we merged that to calculate this to calculate the error. Otherwise, the intersection, that probability of head is 0.5 and t is greater than 55 will be empty, isn't it? Because we said
Yes.
a
Yes,
complement,
ma'am.
t greater than 55 means probability of head is 0.6. So when you intersect with it, there is no intersection, right? Even
Yes.
though they are completely different quantity, we cannot take intersection also. Okay. So after that, this was one of the thing, that how do we calculate error. Okay. So after that, there was one thing, as we discussed initially only, that there will be a two-tailed test, one-tailed test, this kind of stuff. For example, in that bulb kind of test, if they are saying that average lifetime is 75, then we will be interested in one taste or one side taste only. Why one side or one tailed test? We say this sometimes look like this, maximum of the time actually. So whenever I will say, whenever it's more than 85 hours or even more than 65, 75 hours also, I will say I will accept bulb B, right? I will not say I will reject I will reject this uh, company B bulb if it's lasting for 95 hours. So this kind of stuffs are called as one-sided test. But I think with example, it will be more understood. So let me just introduce. Okay, one sample test and two sample test. Now, what does it mean by that? One sample test and two sample test. Anyone can give example. We have actually discussed this unconsciously. So, what does it mean by one sample test? Whenever we are searching for, we are finding the facts for one thing only at a time by observing one samples, like one kind of samples, and it's a one sample test. For example, that bulb example, company A bulb, company B bulb. But whenever we are looking for the company B bulb, that whether its lifetime is more than 75 or not. In that case, we will only take into consideration the samples of B only, right? And we'll check whether it's more than its lifespan is more than 75 or not, right? So this
Yes.
kind of stuff is one sample test, because uh, there is nothing to do with company A bulb. But whenever it comes to choose whether to choose company A bulb or company B bulb, at that time it will be a two sample test. Why? Because now we are checking the time of A bulb and time of B bulb. We will compare between them, whether it's greater or not. So in this case, our null hypothesis will also look like this. For example, let's say TA is greater than B, or T is less or equal to. Okay, are you getting it? Like this kind of stuffs are two sample tests, where two samples are taken into consideration. And here, whenever we deal with the one sample test, significance level will be our main metric to make any prediction. But whenever it's a two sample test, in that case, power of test will be used. But we will learn this thing slowly. Okay. So I'm just introducing it. In hypothesis testing, we will have one sample test also and two sample test, and more than that also. But that is out of the scope for this course. Okay. Any doubt till now?
Ma'am, in the
Yeah.
previous example which you have done, should not we take also the lower range for T? Like we are taking less than 55. Should not we take also greater than something?
You can take. We can take. I just told. We generally have this C.
Okay.
Okay.
Yes.
Yeah. Good question again. Just look at here. In this particular question, I just randomly chose 55. But generally, we do not perform test like this. We do not fix C. This is C only, right? Okay, we just say T less or equal to C. We do not fix this C first. We fix our significance level first. Okay. That means error. So generally, alpha, the value of significance level is generally, we take it as 0.05. Okay.
Okay.
Okay. So once it is 0.05 and let's say we have not fixed C. In that case, what will be our alpha? Alpha will be probability of what? T is greater than C, right? T is greater than C, given that probability of head is equal to 0.5, isn't it? This one is our type 1 error. So this will be a binomial,
Yes,
right?
ma'am.
As we did with the number. So this will be summation k is equal to C plus 1 to some 100, and out of 100, some k are there, 1 by 2, raised to the power 100. Okay. So if I fix my alpha as 0.05, I will be able to find what the value of C should be,
Yes, ma'am.
right? So from this, by fixing this alpha, we will calculate what is the value of C. C is actually something called as critical value. Not always, but sometimes.
But we are always taking T greater than C. Can we take like T less than C also?
Depends on our what we have decided for our null hypothesis.
Yeah.
We have selected our acceptance region as T less or equal to 55. So whenever it comes to rejecting a null hypothesis, I will obviously choose T greater than C, right? Because I have selected my null hypothesis T less or equal to C.
It depends on null hypothesis.
Yeah.
Okay.
So yeah. Okay. Then any doubt? So should we move to the next topic, Z test?
Yes, ma'am.
Okay. So in Z test, what is Z test? Now let's just discuss that. It says that let's say there are some IID samples, okay, X1, X2, Xn are some IID samples. They are following some distribution, okay, and what will be, and we say like we have fixed our null hypothesis and all these things, and we got to know that our significance level is given by alpha is equal to probability that X bar. What does it mean by X bar? Yeah, anyone?
Sample mean.
Yeah, sample mean. Given that mean is equal to 0. Okay, let me just form the question only. Let's say it's a IID and normal sample again. With some mean and known variance. Just take any variance. Let's take 25 fine.
Yes, ma'am.
So mean is unknown. So obviously the whole thing is about to mean whether the mean is 0 or not. Okay. So let's say our null hypothesis is mean is 0 and alternative is, let's say, mean is not equal to 0. Okay. So what will be our significance level? Generally, we if n IID samples are there, I am just taking it my, okay, this is my test statistics. We just say it as a test statistics. Why it is test statistics? Because see, everything we are looking on this is based on this t. We generally say t is greater than c, right? Have you checked that? And here also I wrote t greater than 55. So t is my test statistics. Now in the question or in the just context, I got to know that my t is nothing but the average sample mean. Okay.
But the T could be anything.
Yeah, t could be anything, but just look at this question. We have n IID samples that are normally distributed with mean new and variance 25, right?
Yes, ma'am.
So this is something about my population distribution, right? And I am predicting about my sampling. So if I have to predict, I have to check about the population mean. Obviously, I will take my sample mean, right? So by default here, it should be a sample mean because I am going to discuss about the population mean. So what should be my test statistic? What should I test in that case? Obviously the sample mean, right? If maximum of the sample with more of the confidence give me that, okay, the sample mean is going to 0, then obviously the population mean has to go to 0, right?
Yes, ma'am.
So that's why I choose my t as a sample mean. That is great if it is greater than c and greater. So I just calculated my significance level. Just recently I told that first we fix this alpha significance level. Generally, this significance level we choose at 0.05, 0.01, and then lower than that. Generally, these two are very like we use this only because we always we want less error, right?
Yes, ma'am.
Less and feasible error also. Fine. So now, if we want to calculate this probability that x bar is greater than 0, see, given that mean is 0, how to solve that? So it is given that x is following what? Normal distribution with mean new and variance 25. So what should I do? I can do one thing. My mean is 0. Okay. So can we do something that we used to do with the z thing, z scores? X bar minus mean upon variance. Do you remember?
Yes, ma'am. CLT, central limit theorem.
Yeah. Given that, why I took this mean here? Okay, just let me.
We're centralizing the
Centralizing to 0,
Centralizing
ma'am.
it to so that it will become just a minute. So what I will do here, c minus nu upon square root of variance. Yeah, what should be variance here? So given that nu is equal to 0, so should I remove it here, remove it from here, and just put 0 here? Is it fine?
Yes,
Yes.
ma'am.
Okay. Then what is variance?
It's 25.
sigma square by n.
Yes, it's a 20 square root of 25.
5 by n.
Okay, so it will be somewhat x bar upon 5 upon square root n.
Yes, ma'am.
Yes, ma'am.
Okay, greater than c upon 5 upon square root n. Then this quantity is following standard distribution, right? Standard
Yes,
normal
ma'am.
distribution. So can I say that this is probability z is greater than c
C
square root
by
n upon 5?
yes,
So
ma'am.
my alpha is what? 1 minus
1 minus fz of c root m by 5.
Okay, and we know that these quantities are either given or some hints are given there, right? Okay,
Yes, ma'am.
so using that, we will be able to find the value of alpha, right? And they says we will reject H naught if T is greater than C. C. That we have already given here, right? H naught is mean is 0, and we are rejecting null hypothesis if X bar is greater than 0. Now, we will be able to calculate this alpha value using that C and all this. If alpha, n will be given to us, how many random variables are given there. Let's say some 40 random variables are given there. Okay, n is equal to 40, and alpha generally we decide by ourselves. So let's say alpha is 0.05. So by using all this value, we will get some value of C, right?
Yes, ma'am.
Let's say C is equal to C1, some number. So in that case, if my C1 is greater than C, then what I will do?
Reject the ones.
I will reject null hypothesis, right? Reject null hypothesis.
Ma'am, she will be given to us, or
C will be some number that will decide that whether
okay,
to
we will
accept
decide.
on the basis of that or not. So generally you just take it as like that. Okay, it's my mistake actually. Let's say we got to know that our C is somewhat equal to C1.
Yes, ma'am.
Initially, I told that we will reject null hypothesis if T is greater than C. Now, what is C here? We got to know that this C is nothing but this number C1, this particular number C1.
C1.
Okay, let's just take any random number. Okay, we got to know C1 is fine only, right? Now just assume that C1 is specifically some number. This is not unknown now because we know n, we know the alpha. Then we put all this value here and we got to know that our value of C is C1. Okay.
Yes, ma'am.
So initially we were in the doubt that T X bar greater than C. But what the value of C is there? We don't know. Right? But T was equal to X bar, T was sample mean, right? If we know all the samplings and now just look at that. Now you have the actual values of this 40 random variables, then obviously you are able to calculate the value of T, right? Let's say your X1 is some
Yes, ma'am. We can
45
find.
and all this X40 values are given to you, then obviously you will be able to calculate this T is equal to X bar is equal to, let's say, some value. Let's say you got some value B, okay? Now,
Yes.
if this value B for this particular sampling is greater than C, then greater than C1, then what's your answer? Then you will say that reject null hypothesis. Why? Because we got to know using this above test that whenever with this condition n is equal to 40 and significance level is 0.05, in that case, if the T is greater than C1, then reject null hypothesis, right? Are you
Yes,
getting it?
ma'am. Yes,
So
ma'am.
if sampling is given to you, you will calculate the sample mean, and if it is greater than C1, you will say that, okay, reject null hypothesis. In that case, the language we use is we say that, in that case, we will say reject H naught with significance level 0.05, right? With significance level 0.05. We will say that reject null hypothesis with alpha is equal to 0.05. Or in another language that will come in future, that will say that reject null hypothesis. That means what? What was our null hypothesis? Mean, population mean is equal to 0. We will say that reject null hypothesis with confidence of 95%. That will come in later. Okay. So with 95% of confidence, we will reject null hypothesis. That means that, okay, that implies that. But for time being, do you understand what we have done here? Let me just revise it again. Let's say there are 40 random variables. Okay, remove this n and make it as 40. Okay. Let's say there are 40 random variables that are independent and identically distributed, and they are distributed normally with mean mu and variance 25. You know the variance, but you do not know what the mean is. So now we assumed two hypotheses. Null hypothesis says that mean is 0, and alternative says mean is not equal to 0. Also, we decided our accepted region. Acceptance region is what? Whenever the mean is less or equal to C, you will accept H0. Okay, that we have decided. So on the basis of that, but we do not know what C should be, because if we have 40 random variables and sampling is provided to us, then on the basis of that we will be able to calculate the sample mean, but we do not know what the value of C should be. So for that, we will calculate we will fix our significance level to 0.05 and try to find out the value of C. So what is
Ma'am,
significant?
every time it will be 0.05.
No. It will be either 0.05, 0.01, or it depends on you, or it might be given to us in the question that what significance level it's.
Ma'am,
they-
but if reality we are doing it, then we have to look at the condition, right?
Yeah, what? Can you please repeat?
If in real life, if we in real life we are doing it, then alpha should be means should be set by us only.
Yes. So generally we like to have 95% confidence interval. That's why I'm using that confidence word, right? There is one more concept after that. On the basis of that, we decide this value of significance level on the basis of many factors. So actually this is just an introduction that, so I'm just telling that we generally we take 0.05 or 0.01. Okay, later on you get to know that why I said this, but because it refers to confidence interval, and generally we like to say anything with a good amount of confidence, right? For example, have you ever booked your train tickets? So they says if it is in a waiting list, there is something given to us, right? That 63% of chances that this
Yes,
ticket
ma'am.
will get
There are
confirmed,
chances there. Given.
right? So
Yes,
that
ma'am.
is what, that is something with some percentage. They are telling you that these are the percentage that your ticket might get confirmed, right? So sometimes it is 63%, sometimes it is 95%, sometimes it is 30%. Have you observed that?
Yes, ma'am. It's
Yeah.
different.
So on the basis of such a things, we will, like, there are many factors on which we decide what significance level should be. Okay, but let's fix for let's take any value. Now you can take any value just for the practice purpose.
Ma'am, also can you take an example for two-tailed test after this?
Yeah, I don't think so time will permit today, but in that solve it session, definitely there will be a question based on the two-tailed test. But okay,
So what is this test, ma'am?
Yeah.
What is this test? Is this a test, ma'am?
Yeah,
what
it
you have-
is actually one-tailed test.
Right tail, right?
Sorry, it's a two-tailed. Why it's one-tailed? It's a two-tailed.
two-tailed test.
How did you get to know that? See,
Ma'am, this is right tail, right?
no, this is two-tailed. Mean is 0, mean is not equal to 0.
Oh, yes, it is two-tailed.
So it will be, let me just, It will be like something our distribution is following, let's say this normal distribution, mean is 0 is somewhere here. We are taking alpha is 0.05, so 0.0425 somewhere here. Okay. So whenever the values will lie here, we will, that means sample mean will lie here, we will
Reject.
reject null hypothesis. And
Yes.
whenever the sample mean is lying here in this portion, we will accept the null
Null.
hypothesis that mean is 0. Okay. Fine.
Okay.
That was diagrammatically, but just look at mathematically how it works. So, is there any doubt like how we proceeded with it? I fixed significance
Ma'am, but
level. Yeah.
this is two tails, so why are you taking greater than? You should take greater than, less than both simultaneously, right?
Just a minute. This two-tailed and one-tailed do not depend on these factors. These are taste statistics. Okay, this is something what based on what you are going to decide whether you are accepting or rejecting. Okay,
Okay, ma'am.
so this particular graph is not about the sample means. This will not look at sample. Okay, by mistake I told sample means. This particular graph will take into considering mean values. If it's in between that, I will accept like alpha values. Okay, but but we should not go into that because that will more confuse you. If there is some real life problem, I will try to discuss with it. Okay,
Okay, ma'am.
let me just tell me this: if this procedure is okay with you or not?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Okay.
Okay,
Yes.
so we fixed alpha, then we calculated C, and then we went for the real sample that might be given to us. On the basis of that, we checked whether we have to reject or we have to accept. Now, for one tail or two tail, let me just think. If I get something for it that make it easy, then I will introduce it. Otherwise, it will confuse. So I will suggest just so this was what Z test. Why it was Z test? Okay. Now there is one more thing that is known as p value. Do you have any idea what is p value? So p value is also it's actually more used things. Generally, we use Z test or p value test. So what p value is? See this value C. This value C1, right? I just told you that whenever the sampling is given to us, some B will, like, you calculate the sample mean and it came out to be B, right? Sometimes this test statistics in one of the sampling, P value is nothing but the lowest significance level at which we reject the null hypothesis. Okay, let me just write it. It is nothing but the lowest significance level.
At which the null space will be rejected.
Yeah. Null hypothesis or H naught will be rejected. So obviously there will be some particular value that is known as critical value rejected for some value. T means test statistics. For the above example, T was X bar, that is sample mean, okay, for some particular value T.
We will put C is equal to T in the
Yes,
computation of alpha. We will get P
exactly.
value.
Is said to be P value of the sampling. So that is one of the things that we do here. Let's say for this particular example, sometimes we have given with this critical value. Let's say t is equal to some 240. That means the sample mean is equal to 240 is actually too much because we are testing for the zero mean. So let's say t is equal to 10. That is t is x bar, right? In previous example. Are you getting me right here? X bar is greater than c. This t test statistics was a sample mean for this particular one. So for t is equal to 10, when you search for the significance level, that is what known as p-value for that particular. For example, for above example, where there was n is equal to 40 and what t is equal to 10. So t is equal to 10 means this is the value of c, right? X bar
Yes,
is
ma'am.
greater than c. Okay, and n is
C is
equal
equal
to,
to T.
yeah.
Then
And what
small t is equal
alpha
to
was not given.
40.
Okay, fine. So now alpha will be what? This part. Z is greater than c square root n 5. We got to know that, right? Alpha is equal to probability that z is greater than c square root n by 5. So I am finding for the p value. P value is probability of
Z greater
general,
than
yeah,
Z
c is
greater than 10 root n upon 5.
40 by 5. So whatever the value we'll get from here, that is nothing but our
Fz
p
of that.
value. Yeah, 2 square root 45. So this will be our p value for this particular sampling. When the samples of 40 random variables are given to us, that will be this will give us the p value for that particular sampling. Okay, and this is also the lowest significance level at which this 40 sample test will get to fail or will get to reject the null hypothesis. Okay.
When math session has also started.
Okay, fine. So I am just leaving. Okay. So did you guys understand what is hypothesis, how Z test and p-value test will work? We will
Yes.
do some example in next session and try to understand it more. Any question?
In brief, can you explain the type 2? Type 1, I understand. Type 2 error in brief, if you have time.
Yeah. Okay. Anything else?
No.
Okay. Type 2 error is what? Whenever we accept null hypothesis, but alternative was true. Type 2 error.
So the same is type 1 also.
No, in type 1, we rejected H0 even though it was correct.
Okay.
H0 was correct, but we rejected it. And type 2 is
Okay.
we accepted null. Yeah. Sorry. We accepted null hypothesis.
But it was not true.
Yeah. But H0 or HA alternative was true.
Got.
Was true. For example, that fire example, fire alarm.
Yes.
There was actual fire, but someone accepted null hypothesis. What was, for example, there was no fire. They said there was no fire, but actually there was fire. So alternative was
Yes.
true, but we rejected null. But we accepted null. In that case, we should reject null and accept alternative that there is a fire.
Okay.
Are you getting it? Let's say
In type 1, it is there is no fire. Uh, there is no fire, but we tell that it is fire and we accepted it.
yeah,
Okay.
and let's say there is, okay. Like
Ma'am,
yeah,
can we, let the H0 to be there is a fire and H1 there is no fire?
it depends on situation. Even though I have changed it here, let's just take, because for this particular discussion we do not have any context here, so we can take anything. But once
Okay.
there is a context and everything is there, at that time it matters what is your H naught and what is the. Okay, I do not know where we discussed it. Yeah, but see, it was just a understanding purpose, so we can take it. But once there is particular context is given to us, then we cannot take anything as a null hypothesis. Okay, just be careful
Okay,
about that.
ma'am, got it, ma'am.
Okay, anything else? Any questions?
No, ma'am.
Okay, so see you soon. Just practice it. We will do some questions in next session, so it
Thank
will
you,
be
ma'am.
more clear. Yeah, thanks.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you, ma'am.